I'm about to show a video on multi-step equations with variables on both sides. Before you watch, just a couple tips when you are watching any video related to math or academic content. The first thing you want to watch out for when you're watching math videos or any academic content videos is you want to stay away from what I call TV mode. What do I mean by that? When you're watching TV, you're laying on the couch, eating popcorn, you're relaxed, you're not thinking. Academically, we want to be a little bit more engaged. You want to be part of the film. So, as part of that, press pause occasionally. Especially when I'm about to deliver a new problem. Press pause, take out a sheet of paper, see if you can do it on your own. You don't need to show this paper to anybody. This is for your own personal benefit. But you always want to make predictions and see what the answer might be. That way, even if you're wrong, you've trained your brain to know that, oh, I was trapped in this particular problem. This might be an issue. Or, oh, I got this without ever even thinking ahead. I might be pretty good at this. You know what to focus on when you're studying. Of course, you want to remove distractions. I know for me, when I watch TV, I often have my cell phone nearby, which is fine for watching TV because I'm not going to be quizzed on my favorite TV show. But eventually, you're going to want to know what you need to do academically to be successful. And if you have your phone during an important part of the video, you might not catch what you need to catch. Lastly, this is going to seem like a weird suggestion, but delay rewatching the film. So you might get distracted, like I said. In that case, you should rewatch. Inevitably, somebody might yell to you from another room, and it kind of throws your focus off. If you delay rewatching, though, what I mean by that is you watch it today and you feel pretty good about it. If you have a quiz on something 4 days later, rewatch it those 4 days later, because a lot of the things that you thought you got pretty good in the moment of watching the film, you might not get as well 4 days later. You might have forgot some things. So when you have a problem with variables on both sides, the first thing that you want to do is put all the variables on one side. So right here, it looks like I'm subtracting 4x, and you can call this subtracting 4x, or you can even say that this is negative 4x. It really makes no difference in the way that you think. What you want to do, though, is get rid of that negative or get rid of that minus by adding 4x. So those cancel out. Whatever you do to one side of the equal sign, you have to do to the other, so I add 4x to the right side here. And now this looks like the problems that you're familiar with. Negative 5x is the same as 10, so if we divide by negative 5, you end up with negative 2 is the same as x. And over here, I just checked the work real quick. So we have 10 minus 4 times negative 2. That turns into 10 plus 8, because remember, this is a negative. And on this side, negative 2 times negative 9. I rewrote them, but that's okay because it's commutative. I should really have negative 9 here first. And that equals 18, and of course 10 plus 8 is 18, so you know that this checks out. The equation is balanced. This one seems a little more complicated, but it's all stuff that you have seen before. We're going to distribute the 3, which means we multiply. And I'm also going to distribute the 1/4 here. So 1/4 of 32 is the same thing as doing 32 divided by 4. Remember, if you multiply by the reciprocal, that's the same thing as division. And 1/4 of 56 is 14. 56 divided by 4 is 14. From here, you can do this 2 different ways, and I'm going to show you both. So my preferred way is to take 8x from both sides. And now you can see I've got a regular one-step equation, so we just got to add 12 to both sides, and you'll end up with x is the same as 26. Now just to show you, I'm going to go back to this step right here. Instead of taking 8x, I'm going to actually add 12. I could start anywhere I want with this. I could start here at 9x. I could start here with minus 12. It won't make a difference in your final result. So if I add 12, I'll end up with 9x is the same as 8x plus 26. And then I would take 8x on both sides here. Get rid of the x's. The reason I'm attacking 8x instead of 9x is because 9x doesn't really have a constant term over here. I call this 26 a constant term, and 8x does. So I'm going to put all my constant terms on one side, all my variables on the other. And of course, we end up with x equals 26 Either way you choose. I'm going to skip the check, but of course to check, you would plug the number back in for the variable. Right here, similar idea. The one thing I think that's different is you have a minus y right over here. So we're going to have to do what we call combining like terms. So I would first distribute again. What I want to point out is the 20y minus y. Again, you might want to pause the video. It makes it a little bit more challenging on yourself. That way you're not entering TV mode. But the way I interpret this minus y, if you want to put a 1 in front as a coefficient, the number in front that you multiply the variable by is called a coefficient. You can do that. So 20y minus 1y is 19y. And now we're back to sort of familiar territory. My preference is to get rid of the variables, but just to show you can do it any way you want, I'm going to get rid of this 20 first. So you'll notice I'm putting all of the constant terms, all the numbers, on the right-hand side. Negative 16 minus 20, by the way. That might be difficult math, or it's the type of math that can trip you up. So I like to add 16, but I just wanted to show you that you can take 20 and you can work with the negatives. Now that I've got this, I'm going to take my 16 y's and move them to the other side. So I'm getting all the y's on one side. 3y is the same as negative 36. If I divide by 3, it looks like y will equal negative 12. All right, this last one's a little bit of a brain teaser, and maybe press pause, try to see if you can do it on your own, but 2 times the greater of 2 consecutive integers is 9 less than 3 times the lesser integer. What are the integers? Whoa, right? So I'm going to call the greater of the integers x, because consecutive means that they're back-to-back, so like 7 and 8 are consecutive numbers. And I'm going to call the lesser x minus 1 since they're consecutive. So it has to be 1 less than. All right, of course, this integer means it has to be a whole number. It could be negative, but it has to be a whole number. And if I just read it the way it's written, 2 times the greater. Now, the greater is x, so 2 times the greater would mean 2 times x. This word is very often is interpreted as an equal sign or the same as. So 2 times the greater of 2 consecutive integers is the same as, I think that makes sense to put the equal sign there, 9 less than. Whenever you have this phrase less than, if I said to you, what's 9 less than 15? Hopefully you'd say 6. And even though I said 9 first, I said 9 less than 15, and I said 15 second, really in the process there, we were doing 15 minus 9. So it looks like when they say 9 less than, at the end of this, we're going to say minus 9. 3 times the lesser integer, and the lesser integer is x minus 1. So 3 times x minus 1. And now from here, I can just do the math out. Now you've got a minus 3 and a minus 9. Those are like terms. You can combine those to call them negative 12. And then finally, if I put all the x's on one side, you're left with a statement that says negative x is the same as negative 12. Now when you have a negative in both of these, in the end it's going to be x equals 12. And I'm going to show you why. If I put the coefficient here that you can't see, negative 1, I'm going to divide by negative 1, divide by negative 1, and a negative divided by a negative is a positive. So you get x is the same as 12. And I think it helps to go back and look at what the question was asking. It says, what are the integers? I haven't really answered what they're asking. But x we said is the greater integer, so if the greater one is 12, the other integer has to be the lesser one. So the other one, if they're consecutive, has to be 11. And if I actually plug that in here, 2 times x, remember I said x is 12. 2 times 12 is 24, and then 12 minus 1 is 11. 11 times 3 is 33, and they said 9 less than, so that's the 24 right there. So 33 minus 9 would be 24. It checks out.